All right, so are you ready to dive into something kind of creepy?
Oh, yeah. Always up for a little bit of
That's
creepiness.
okay, good, because today we're talking about robot cybersecurity.
Ooh, robots. Sounds interesting.
Yeah, and it's not just some far-off sci-fi stuff either. We're talking about real security risks with robots that are already out there, like in homes, businesses, you name it.
So like those robot vacuums people are obsessed with.
Exactly. Even those can be vulnerable. The source for this deep dive is a report called Hacking Robots Before Skynet from IOActive. It came out back in 2017, but it's still super relevant.
Hacking robots before Skynet.
Yeah.
I like a catchy title.
Right, and the report doesn't just talk about the theory of hacking robots. They actually went and did it. Hacked into some popular models to see just how vulnerable they are.
That's what I call hands-on research.
Right. So before we get into the nitty-gritty of how they hacked these robots and what they found, I think it's important to understand just how big this whole robot revolution really is.
Huge, right?
Huge is an understatement. The report mentions that by 2020, the robotics market was projected to reach a whopping $188 billion.
That's a lot of robots.
It is. And even back in 2017, when the report came out, countries like South Korea were pouring tons of resources into robotics research and development.
We're talking major investments from big players like SoftBank, UB Tech, and even venture capitalists.
Exactly. Everyone was jumping on the robot bandwagon. And it's not just those big industrial robots you see in factories anymore either.
Nope, we've got robots in our homes now, in stores, even assisting with surgeries.
I was just going to say that think about SoftBank's Pepper robot, that little humanoid designed to interact with people.
Or those surgical robots that are being used more and more in healthcare. Pretty mind-blowing stuff.
It is exciting, but it also kind of makes you think about the security implications, especially after reading this report.
Okay, yeah, that's where things start to get a little creepy.
Exactly. The report talks about something called the kinetic IoT problem. Have you heard of this?
Kinetic IoT. Not ringing a bell.
So basically, it's this idea that robots aren't just computers anymore. They're computers with arms and legs. They can move around and interact with the physical world.
Okay, I see where you're going with this.
Yeah.
So if someone hacks into a robot, it's not just about stealing data anymore.
Right. It's about potentially causing real-world harm.
Like a hacked robot going rogue.
Exactly. The report actually mentions some real-life robot accidents that have already happened, even without any hacking involved.
Like what kind of accidents?
Well, there was that tragic case back in 2015 where a woman was killed by an industrial robot in Alabama.
Oh, wow. I vaguely remember hearing about that. That's awful.
Yeah, it was a horrible accident. And while that particular incident wasn't caused by hacking, it really highlights the potential for harm when robots malfunction or are intentionally misused.
It's a stark reminder that security isn't just some theoretical concern with robots.
Yeah,
It can have very real and very serious consequences.
exactly. And that brings us back to the IOActive report. They didn't just theorize about these risks, they actually dug into the code of some real-world robots.
So they were like digital detectives.
Kind of. They analyzed robots from companies like SoftBank, UB Tech, Robotics, even those big industrial robot arms from Universal Robots.
What were they looking for exactly?
Vulnerabilities, security flaws, anything that a hacker could exploit.
And did they find anything?
Oh yeah, they found a whole bunch of vulnerabilities, nearly 50 across all the different robots they tested.
50. That's a lot. Does that mean all robots are vulnerable?
Well, the fact that they found vulnerabilities in such a wide range of robots from different manufacturers suggests that this is a pretty widespread problem.
Yikes. Okay, I'm officially creeped out now.
I know, right? And we haven't even gotten to the details of what they found yet.
So let's hear it. What kind of security flaws are we talking about here?
Okay, so one of the most common and concerning issues was insecure communications. They found that a lot of robots were using unencrypted or weakly encrypted communication channels.
Unencrypted, seriously. So anyone could potentially eavesdrop on those communications.
It's like sending a postcard with your deepest, darkest secrets written on it. Anyone can read it along the way.
That's not good.
Yeah.
What else did they find?
Well, another big red flag was weak or non-existent authentication. In many cases, there were no passwords at all protecting critical functions.
Wait, so anyone could just take control of these robots? No password needed?
In some cases, yeah. It's kind of like leaving your front door wide open and hoping for the best.
Not exactly a sound security strategy.
And even beyond that, they found that a lot of robots were lacking proper authorization controls.
Authorization controlled meaning.
It means that critical functions like installing software updates could be accessed and manipulated by anyone, not just authorized users.
That sounds like a recipe for disaster.
Yeah.
What about all the data that these robots are collecting? Is that secure?
Well, that's another area where they found some pretty serious vulnerabilities. A lot of the data stored and transmitted by robots was poorly protected, putting personal information and system security at risk.
So our data might not be as safe as we think it is, even with these seemingly helpful robots around.
That's the scary part. And then there's the whole issue of privacy. Some robots were sending sensitive information like location data to remote servers without the user's consent.
Okay, hold on. So not only could someone hack into these robots and control them, they could also be spying on us.
It's a possibility. And that's not all. They also highlighted the problem of weak default configurations.
Weak default
Yeah,
configurations.
basically it means that a lot of robots come pre-configured with insecure settings right out of the box.
Seriously. So it's like buying a new car with no doors and hoping no one steals it.
It's a pretty big oversight, and to make matters worse, a lot of robots rely on software frameworks like the Robot Operating System or ROS, which has some known security flaws.
So it's like building a high-tech robot on top of a foundation with cracks in it.
Exactly. It's not a good situation, and I think this is where things start to get really concerning. These vulnerabilities might seem abstract, but the report actually lays out some pretty chilling scenarios of how hacked robots could be used for malicious purposes.
Okay, I'm all ears.
Mhm.
Hit me with the worst-case scenarios.
All right, so imagine a home robot being hacked and used for spying on your family, or even worse, causing physical harm.
Wait, hold on. You're saying my robot vacuum could turn against me?
Well, maybe not your vacuum specifically, but the report highlights how a hacked home robot could potentially start fires, manipulate objects, disable security systems, you name it.
Okay, that's officially terrifying. And it's not just homes that are at risk, right?
Nope. Businesses and industrial settings face even bigger threats. Imagine a hacker taking control of a company's robots and causing chaos disruption, even physical damage.
Or even worse, someone hacking into those industrial robots, those big, powerful arms. That could be deadly.
Exactly. And then there's the healthcare industry where robots are being used more and more for things like surgery and patient care.
I'm guessing the report didn't actually test any medical robots, did they?
They didn't specifically test medical robots, but they pointed out that the same vulnerabilities could apply. Imagine a hacked medical robot administering the wrong dosage of medication or even causing physical harm during a procedure.
That's some real-life horror movie stuff right there.
And then, of course, there's the military and law enforcement. They're increasingly using robots for things like surveillance and bomb disposal.
And if those robots get hacked...
So let's just say the consequences could be pretty catastrophic.
Okay, I think I've had enough nightmares for one day. So is there any hope for a secure robotic future? Or are we all doomed?
Well, the good news is that the report doesn't just focus on the problems. It also lays out some concrete steps that can be taken to improve robot security. We'll dive into those solutions in the next part of our deep dive.
Okay, good. Because right now I'm feeling a little more terrified than inspired by all this robot talk.
I hear ya. But before we move on to solutions, I'm curious what surprised you the most about the vulnerabilities we've discussed so far.
Honestly, what really struck me was how many of these problems seem to stem from basic oversights, like not using strong passwords or failing to enable encryption. It's like the manufacturers just didn't prioritize security from the get-go.
I totally agree. It seems like security was more of an afterthought than a core design principle.
Yeah, and that's a big problem. We need to shift our mindset and start thinking about security from the very beginning of the robot development process.
Okay, so how do we do that? How do we actually make sure these robots are secure from the ground up? That's what we'll explore in part 2 of our deep dive.
I'm ready for some solutions.
Yeah.
Bring on the good news. It's amazing to think how quickly robots have gone from, those clunky factory machines to something we might have in our homes.
Right, like we were just saying before, it feels like science fiction is becoming reality, but maybe a little too fast.
But we are talking about a technology that's still evolving.
And it seems like security is playing catch-up. You mentioned security by design before. I'm curious what that actually means.
It means we stop treating security like an add-on. Like trying to bolt a security system onto a house that's already built.
So instead of an afterthought, it's part of the blueprint from the very beginning.
Exactly. You're thinking about security at every stage, from the initial design and the parts you choose to the software and testing.
Okay, that makes sense in theory, but how do we actually do that? Is there some kind of magic formula?
No magic formula, unfortunately. But there are specific steps manufacturers can take. One big one is adopting a secure software development lifecycle, or SSDLC.
Okay, break that down for me. What is an SSDLC?
Think of it like a set of guidelines for building software. But instead of just focusing on making the software work, It also bakes in security at every step.
So finding and fixing security holes before the software even gets released.
Right. It's much easier to prevent problems than to try to patch them later, like building a house on a solid foundation.
Solid foundation, got it. What else can manufacturers do to make sure their robots are secure?
Well, encryption is a big one. All the communication between the robot, the controllers, any external servers needs to be encrypted with strong algorithms.
So even if someone intercepts the data, it's just gibberish unless they have the key.
Exactly. It's like putting your valuables in a vault.
And what about passwords? We were talking before about how some robots don't even have them.
Right. We need to go beyond simple passwords, things like two-factor authentication, or even biometrics like fingerprints or facial recognition.
So making it much harder for unauthorized users to get in, and once they're in, what's to stop them from accessing everything?
That's where access control comes in. Think of it like a company. Not everyone gets the keys to the executive suite.
So the intern might be able to use the coffee machine, but only senior engineers have access to the critical systems.
You got it. It's about giving people access based on their roles and responsibilities. A granular approach.
Sounds complicated. But I guess when it comes to security, complexity can be a good thing.
It's definitely a challenge, but the stakes are high enough to make it worthwhile. The report also talks about the importance of secure default settings.
Yeah, what was that again?
Basically, it means that when you buy a robot, it should come pre-configured with secure settings. Strong passwords, unnecessary services, disabled access to sensitive functions, restricted.
So instead of making the user figure all that out, the manufacturer takes responsibility for setting things up securely from the start.
That's the idea. And of course, there are software updates. They're inevitable, but the update process itself needs to be secure.
Meaning?
Using encrypted channels to deliver the updates. Strong authentication to make sure only authorized users can install them. And the updates themselves should be digitally signed.
Like a seal of approval so you know it's the real deal and not some malicious code.
Precisely. But securing robots isn't just about the initial setup. It's an ongoing process.
So it's like a never-ending game of cat and mouse with the hackers.
In a way, yeah. The threat landscape is constantly changing, so we need to be vigilant about monitoring for vulnerabilities and patching them quickly.
But it's not all on the manufacturers, is it? We as users have a role to play too, right?
Absolutely. We need to be aware of the risks and take those basic precautions. Choose strong passwords. Be careful about what information we share with our robots. Keep our software up to date.
So basic digital hygiene, just like we do with our computers and phones.
Exactly. And be on the lookout for social engineering scams, people trying to trick you into giving them access to your robot or your personal information.
It's easy to forget that sometimes the weakest link in the security chain is us humans.
Very true. Technology can only do so much. We need to be smart about how we use it.
So what I'm hearing is that we need a multifaceted approach to robot security education for developers and users, better security practices from manufacturers, maybe even some new regulations.
It's a complex issue for sure, but I think the most important thing is that we're having this conversation. We're recognizing the problem and starting to think about solutions.
This IOActive report really has been a wake-up call. It's shown us that robot security is something we can't afford to ignore.
It's a call to action. We have the knowledge and the tools to address these challenges. The question is, will we use them?
Okay, so we've talked about the vulnerabilities, we've talked about some potential solutions, but there's one more piece of the puzzle I want to explore. The human element.
I think that's a crucial part of this whole conversation. At the end of the day, technology is just a tool. It's how we use it that matters.
Which brings us to the ethical considerations surrounding robots. As they become more sophisticated and autonomous, we need to think about the impact they'll have on society.
We're talking about things like responsibility, accountability bias, even potential for robots to replace human jobs. These are big questions that we need to grapple with.
So let's shift gears a bit and delve into the ethical side of this whole robot revolution. Join us for the final part of our deep dive as we explore the ethical considerations that will shape the future of robotics. You know, it's funny, I was thinking about something you said earlier about those basic security oversights.
Like the weak passwords and stuff.
Yeah. It really struck me that sometimes the biggest security threats aren't some sophisticated hacking scheme.
It's human error. Good old-fashioned human error.
Right. And with robots, those mistakes can have some pretty serious consequences, like we talked about before.
Exactly. It's not just about data breaches anymore. It's about potential physical harm in the real world.
So education is key, right?
Absolutely.
Yeah.
We need to make sure everyone understands the importance of robot security. From the people designing and building these robots to the everyday users.
So it's not just about the technology itself, but the people behind it.
Exactly. It's about creating a culture of security where
Right.
everyone takes responsibility for protecting themselves and others.
So how do we actually do that? How do we create that culture of security you're talking about?
Well, it starts with education and training. For developers, that means teaching them secure coding practices and making sure they're up to date on the latest threats. For manufacturers, it's about integrating security audits and testing into their processes.
And for us regular folks,
For everyday users, it's about being aware of the risks and taking those basic precautions. Choose strong passwords. Be careful about what information you share with your robots. Keep your software updated. It's really not that different from the digital hygiene we practice with our computers and smartphones.
right. So it's about applying those same principles to the world of robots.
Exactly. And don't forget about social engineering. Be wary of anyone trying to trick you into giving them access to your robot or your personal information.
So education awareness and a healthy dose of skepticism.
Exactly. We need to be smart about how we interact with this technology.
This whole conversation has really highlighted the need for a multi-pronged approach to robot security. We need better technology, better education, and maybe even some new regulations.
It's a complex issue, but I think the most important thing is that we're acknowledging the problem and starting to have these conversations.
This report from IOActive really has been a wake-up call. It's a reminder that we can't just sit back and assume that everything will be fine. We need to be proactive about robot security.
I totally agree. We have the knowledge and the tools to address these challenges. The question is, will we use them?
So where do we go from here? What's the next step in creating this secure robotic future?
I think it starts with awareness. We need to keep talking about these issues, educating ourselves and others, and demanding better security from the companies developing and deploying these technologies.
And we can't forget about the ethical considerations. As robots become more advanced and more integrated into our lives, we need to have some serious conversations about their impact on society.
Absolutely. Questions about responsibility, accountability bias, the potential for job displacement. These are all things we need to grapple with as we move forward.
It's a lot to think about, but it's also an incredibly exciting time. Robots have the potential to transform our lives in so many positive ways.
I'm optimistic that if we approach this technology thoughtfully and prioritize security and ethics from the start, we can create a future where robots enhance our lives without putting us at risk.
That's a great point. It's not about fearing the technology, but about using it responsibly.
It's about shaping a future where robots and humans can coexist safely and productively.
Well, this has been a fascinating and thought-provoking deep dive into the world of robot cybersecurity.
It really has. We've covered a lot of ground, from vulnerabilities and solutions to ethical considerations.
And I think the takeaway here is clear. We need to be aware of the risks, but also embrace the potential of this technology.
It's a balancing act, for sure, but I think it's a challenge we're up to. If we work together and prioritize security and ethics, we can create a robotic future that benefits everyone.
Absolutely. Thanks for joining us on this journey, and as always, stay curious, stay informed, and stay secure.